first of all, we remember congruent polygons are two figures that have the same shape and the same size. That's not what we're learning about today, but I'm just going to show the difference between congruent and similar shapes. Remember, we proved triangles were congruent by side, 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 side angle, side, all that stuff. So if you were asked to list the corresponding congruent parts, remember the congruent statement is a great place to start because the order of the letters has to be corresponding. So we would say segment DJ is congruent to what segment? Marquise? FC. First two letters, first two letters. Second two letters, second two letters. So JT, congruent to CR. And then you can also do the first and last, which would be DT is congruent to segment FR. So those are your three pairs of congruent sides. You also have three pairs of congruent angles. So angle D would be congruent to angle F, angle J congruent to angle C, and angle T congruent to angle R. So those are all of your corresponding congruent parts. If you remember when we did triangle congruence, we only had to prove like side, angle, side. DT is FR. And then once we proved they were congruent, then we could say all the corresponding parts were congruent by CP, CTC. Okay? But the important thing to take away for today's lesson is just the word corresponding. So remember, corresponding parts are going to match up within the congruence, or today the similarity statement. And they are the ones that kind of match up to one another in the picture. So today's focus is on similar polygons, which look like this. Okay? So there are two figures that have this same shape, but not necessarily the same size. So it's almost like one's been shrunk or enlarged. And I have the same picture two places. Now, what you'll notice is that the corresponding angles are congruent. Okay, why? Well, they still have to add up to 180 no matter if it's a small triangle or a big triangle. It's still 180. So the corresponding angles are congruent. So angle U corresponds to angle X, angle V to Y, and W to Z. But the corresponding sides are not congruent. What is the relationship between the sides? Maddie? Yes, if you look at it this way, they're divided by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. And 24 divided by 3. If you look at it this way, it's times 3, right? Okay. So these are called proportional. All of them have that same scale factor that is relating the sides to the sides. So we will say corresponding sides are proportional. Remember yesterday we learned what a proportion was, which is where we set like two fractions equal and we cross multiplied to solve. That's what we'll be doing today when we're looking to find a missing side length. Now the symbol we know for congruence is that, right? Today we're going to learn that the symbol for similarity is just the top squiggle of the congruent sign. So congruence really means that they're similar and equal, making them congruent, exactly the same. The top part is your similarity symbol. So we would say, based on this one, triangle UVW is similar to triangle, you do have to match up the corresponding parts, XYZ. And that would be read as is similar to. The similarity ratio is the ratio of the lengths of the corresponding sides. And usually when we do the similarity ratio, we'll just go from left to right, just like you read a sentence. So if I was doing the similarity ratio for these two, it would be actually, let's put it down here by this. It would be 9 over 3, which reduces to be 3 over 1. 15 over 5, which reduces to be 3 over 1. And then 24 over 8, which also reduces to be 3 over 1. You do have to have all of them being the same proportion. So the similarity ratio would be 3 to 1. You also can write it as a ratio 3 to 1. So those are the two options of how you would write your similarity ratio. All right, below, they give us a similarity statement. So what would give us the similarity statement? So again, the order of the letters makes a big difference. Angle A would be congruent to angle, no? No. Okay. Angle Y. So the picture, if you look at the picture, it's hard to tell because it's been like flipped and rotated. So you do want to focus on the similarity statement that A would have to be congruent to Y because they're in the same location in the corresponding parts when we're doing our similarity statement. So B would be congruent to X, C congruent to W, and D to Z. Now remember, the sides are not congruent. The sides are proportional. So all you're going to do is you're going to write a proportion or several ratios strung together with an equal sign. So they've taken AB, the first two letters, over YX, the first two letters. Who thinks they could come up with another one? There's a lot of them, obviously. Marquise? CD over WZ. Sure. Last two letters, last two letters. Who can give me another one? Maddie? BC over XW. Good. Middle two letters, and then there's one more. It's the one we're missing. No? AD over YZ. Good. AD over YZ. So if all the angles are congruent and all the sides are proportional, then the figures are similar. And you could also use the symbol for similar if you'd like. It's just your symbol. So the next two questions ask us, are they similar polygons, yes or no? If yes, we'll write a similarity statement like this. Letters and the symbol. Make sure the corresponding parts match up. And we'll state the similarity ratio. If it's a no, you literally just say no. And I don't think it even says we have to explain. So, just no. So are these similar? Yes or no? So if you're checking if they're similar, you have to check two things. Angles. Are the corresponding angles all congruent? That has to be true for it to be similar. So looking at our markings, one marking, 2 and 2, 3 and 3. So yes, all the corresponding angles are congruent. The second thing we want to check are the corresponding sides proportional? Okay, to do that, you have to check all three pairs of them. You can do this in your head if you want, but you might want to jot it down so that you reduce each fraction and make sure they're the same thing. So again, looking at your corresponding parts, like 24 would correspond to 18 because they're between the 1 and the 3 and the 1 and the 3. And I'll just go from this one to this one. So we'll say one of the ratios would be 18 over 24. What does that reduce to be? Okay. 3/4. Divide by 6 in the top and the bottom. Okay, now we need to make sure all the other ones reduce to 3/4. So again, make sure you pick the corresponding parts. So this 16 and this 12 are going to correspond. So we'll do 12 over 16 and reduce. Divide by 4 in the top and the bottom. We get 3/4. You could check in your calculator and go 0.75, but whenever you do your similarity ratio, you don't want 0.75, you want 3/4. That's why I say show this work. And then the last one would be 15 over 20, which again will reduce to be 3/4. So since all of these are the same, the answer is yes. Who thinks they could write a similarity statement? Triangle something is similar to triangle something. The first letters don't matter, the second one has to match up. Marquise?
Triangle ABC is similar to triangle FED.
Good. ABC, FED, matching up 1, 2, 3 markings. And they also want us to give this similarity ratio, which is 3/4. So you can either write it as 3/4, or if you want, you can write it as 3 to 4. You don't have to show all this work. You can do it in your head if you want to reduce the fractions, but this does have to be written down. Yes or no, and if it's a yes, you answer these 2 questions. The next one has quadrilateral. So again, first check your angles. So check your angles, 1 marking, 2, 2, 3, 3, 4, and 4. So yes, the angles all match up. If one of them had different markings, you would just say no. Okay. Now check all the sides are proportional. And to do that, again, you want to make sure you look at the markings of the angles. So between the 1 and the 2 marking here is 2. Between the 1 and the 2 marking here is 1. So those are the corresponding sides. So 2 over 1 is just 2 over 1. Okay, now pick another pair of corresponding sides. Between the 2 and the 3 marking is 6. Between the 2 and the 3 marking is your 3. Because they flip the picture around, so don't always think that they're necessarily in the right spot. So 6/3 is 2. So far so good. Keep going. We have our 4 and our 2, so that one definitely works. Now the last one, 7 corresponds to 3.5. If I were doing this without a calculator, well, you should know 3.5 is half of 7, but if you didn't, how can you get rid of decimals in fractions? What can I do to get rid of like the 3.5 and make it a whole number? Jermaine? Yes, if you multiply these by 10, you'll get 70 over 35. And that moves the decimal. Then you no longer have decimals and fractions. And then you could reduce this and see that, yes, this is 2 over 1. So this is a yes. And we would just say like quadrilateral, not a parallelogram symbol. Let's just do quadrilateral. Maybe you might want to go in the order of the marking. So 1, 2, 3, 4, and then go 1, 2, 3, 4. So let's go BADC is similar to quadrilateral 1, 2, 3, 4 FEHG. Again, the order of this one doesn't matter. The second one just has to correspond. And then your similarity ratio would be 2 to 1. Or 2 over 1 if you'd like to leave it. Just don't put it as 2. It has to be a comparison of 2 things. Now on the back, they're going to tell us we have similar figures, and then we're going to use the fact that we have similar figures to actually find out values of the sides or the angles, depending upon where the variables and angles may lie. So again, this is super important to know what is corresponding to what. So we're asked to find what x is and what y is. The first thing you want to do is you want to find the pair of sides that you know both numbers between the two shapes. Okay? So notice LM and QR. LM and QR are corresponding parts, right? First letter, 2 letters, first 2 letters. And we know both of their numbers. That's going to be the ratio you want to start with. So start with that. 5 over 6 equals, and then it's up to you whether you want to do x or y first. You're going to have to do 2 separate proportions. So we did first shape over second shape. So I'll do first shape over second shape. So this would be 2 over x. And then you just cross multiply. 5 times x is 5x equals 6 times 2 is 12. And then you can either leave it 12/5 or we can get our decimal. 2.4. One of those 2 answers. You can round, you're not having to round that, so you can put it as a decimal if you'd like. Now, to get y, I would still stick with the original, the given piece, the 5/6. 5 over 6 equals something over something. What will I put on the other side? Is it 3.2 over y, or is it y over 3.2? This is important. Marquise.
3.2.
Good. You're always doing first shape over second shape. So first shape over second shape. 3.2 over y. These are very easy, but if you want to make sure, like jot down first and second to make sure you put them in the right spot. Because if you put them in the wrong spot and cross multiply, you'll get the wrong answer. And then we just cross multiply that. We get 5y equals 19.2 divided by 5. Get y is 3.84. See if you guys can try example B. In that one, you're asked to find the values of v and t. So in case you're having trouble seeing them, v is located here, which is like this side length, and t is located here, which is this side length. Again, use your similarity statement to help you figure out what is corresponding. Again, when you're doing these, you want to find the pair of numbers that you have corresponding sides that are both given to you. So start out with that. 5 over 3 equals, and then notice your corresponding sides would be 8 would correspond to v. So that would be 8 over v. First shape, second shape, first shape, second shape. Cross multiply and get your answer. When you do t, you still want to stick with that 5/3. I mean, you could use the 4.8 if you want to, but I don't suggest it in case you did something wrong to get that. And then for the second one, you should have 5 over 3 equals t over 6. Do not think, oh, it always goes in the top, the variable. Or, oh, it always goes in the denominator. It's going to be different for every question. Okay? And then you get 3t equals 30, t is 10. All right, last one before I pass back your test. It says, assume the two triangles are similar. I heard a couple of you talking about this. Right now, you guys might see a triangle and what appears to be a trapezoid, but what they're talking about is the triangle within the triangle. Okay? It may benefit you to redraw them. You don't have to, but if you don't, there's a good chance that you may set up your proportion wrong. Okay, so the small one has side lengths 5 and 4. The big one has a side length of x. How long is this total side? 8. If you don't redraw them, there's a good chance that you might do 5 over 3 equals 4 over x instead of 5 over 8. Okay? And then you would create, it tells us that they're similar, so we know that. We can solve using a proportion. So I would say 5 over 8 equals 4 over x. And then we cross multiply. 5x equals 32. Divide by 5, and we will get x equals 6.4. So just make sure you do realize that this whole side is 8 and that you don't do 5 over 3 equals 4 over x, because that will be getting you a wrong answer. Okay. See if you guys can complete the closure. Notice that it asks you to find some angle measurements. What do we know about the angles in similar polygons? Well, they do equal 360 for a quadrilateral, but in a similar shape, what do we know about the corresponding angles? They're congruent, okay? So just look at your similarity statement, to figure out which angles will be the same, and you can use 360 if you need to. But the sides are not congruent, those are proportional. So see if you guys can finish that out, and I'm gonna pass out your homework and then your tests.